Hi everyone, in this video we're going to talk about how to solve systems of equations by elimination. Please note that I've heard the elimination also called linear combination or the add-subtract method. They're all very similar. We're essentially going towards the same goal. So I'm going to describe how I do elimination. It may be slightly different than how your teacher describes it, but we're all doing very similar things. I like to present it just one way so that for any problem you could do it the same way throughout. So we'll talk about that as we go through. And just like in the last video, some of the steps, it's easier for you to actually see them done than to just read them as words on a page. So I'm going to go through the just the steps in words, and then as we do some of the problems, it might make a little bit more sense. So you can always come back to this frame and reread through the steps if you need to. So first thing we're going to do is get both equations in the same order. And what I mean by that is that if you have x and y on the left hand side and some number on the right hand side, you want the other equation to be in that same format. X and y on the left, some number on the right. If x is on the left, y is on the right, you want it for the other equation also. As long as they're in the same order, then you can proceed. If they're not, you would just need to rearrange it so that they're all everything will line up. Okay, the second thing you want to do is look for what I call a pair of opposites. So what I mean by that, if you have positive 2x in one equation, you want a negative 2x in the other equation. If you had negative 6y, you want positive 6y. You just need one pair of opposites. You don't always get that though. If you don't have them, we're going to multiply one or both equations if we need to by some number to get a pair of opposites. Okay, and then once you have that, you're just going to add the equations together. And when you do that, mathematically, one of your variables is now going to be eliminated. Hence the name of this method, the elimination method. Okay, so once that variable is gone, you're going to have one that's left. Solve for that variable. That's one part of your answer. Use that answer to solve for the remaining variable. Give your answer as an ordered pair, just like we do for all systems, and then check. Okay, so I'll leave the steps on the side. Let's see if we can see them both in the screen. Yep. Okay, so let's give it a shot. Okay, so the first thing I want to do is make sure that they're in the same order. So I have my x and y on the left-hand side equals some number. X and y on the left-hand side equals some number. So they're in the same order, that's great. So now I can move on to step 2. Look for a pair of opposites. So, and now you want a pair, either the x's or the y's, it doesn't matter. So I have a positive 2x here. I'd really like that to be a negative 2x. Is there some easy way that I can multiply this equation by something to make that be a negative 2x? Yeah, I can multiply this whole thing by a negative 1, and then I'd have a negative 2x there and a positive 2x there. Let's just check the y's, see if it would be easier. I have 3y here and a 5y here. There's not really an easy way for me to multiply to get the y's to be a pair of opposites. The best I could do would get it to be a negative 15. So I'd have to multiply this by a negative 5 and this by a positive 3, but that's so much work. Why do I bother when I just have to multiply this by a negative 1 to get a pair of opposites for my x's? So let's go ahead and do that. And it doesn't matter if I multiply this one by a negative 1 or this one. I just want one of them to be a positive 2x and one to be a negative. So if I write that, I'll distribute that negative 1. Negative 2x minus 5y equals, remember to distribute over here too. Negative 1 times negative 1 is now a positive 1. Okay, so now I do have a pair of opposites. I have a positive 2x and a negative 2x. So I'm ready for step 3. I'm going to add the equations together. So to do that, I'm just going to rewrite them on top of each other. So I have 2x plus 3y equals 7, the first one. And then underneath it, I'll write negative 2x minus 5y equals 1. And I'm going to add these two equations together. Well, 2x plus a negative 2x so cancel each other out. Positive 3y plus a negative 5y is a negative 2y. And 7 plus 1 is 8. So notice, just like we said over here, one variable should now be eliminated. It was. The x's are gone. So now all I have left is y. And I can solve for that y. So y is going to be a negative 4. So that's just step 4 that we did. I have one part of my answer. Remember, it's always x comma y, and I have the y part. Okay, so now what I want to do, I'm going to go back. I'm going to go to my other equation. I'd recommend using the original. It's not a big deal if you use this one, as long as you... The only reason why I say go back to the original is what if you happen to mess up right here. But then I guess the whole thing would be wrong anyway. So I usually go back to the original though. If I know that y is now -4, let me take my original, 2x plus 5y equals -1, and I can plug in a -4 for y. 5 times -4 equals -1. And now I can solve for x. 5 times a -4 is a -20 equals -1. I can add 20 to both sides. And I get 2x equals 19. Divide both sides by 2. And in this case, I'm going to get 9.5. So now I have x is 9.5, y is -4. Okay? Let's take a look at this one here. Let's see. So I want to get both equations in the same order. Okay, well, I have x and y on the left here equals some number. I only have y on the left-hand side here. So what I'd like to do to get them in the same order to even begin, I'm going to subtract this x so that I have both x and y on the left-hand side. I could have just as easily subtracted the x over here, so I just had y on the left and then x and the number on the right. But I usually like to keep it in standard form, so I'll subtract x from both sides. -x plus y equals 4. So now they are in the same order, so step 1 is done. Now in step 2, I want to look for a pair of opposites. So, as it turns out, I have one. I have a positive x and a negative x. So step 2 is already done for me. I don't have to multiply either one by anything because it's already done. So in step 3, I'm going to add the equations together. So I'll just write them on top of each other. X plus 4y equals 1. And this one, -x plus y equals 4. I'll add those two together. X plus -x cancels itself out. 4y plus y is 5y. And 1 plus 4 is 5. So I can solve for y. And it just so happens that y is 1. Okay, and now I can go back to my original equation over here, y equals x plus 4. I know that y is 1, so I can solve for x. If I subtract 4 from both sides, -3 is x. So now I have my solution here is -3, 1. Okay? Let's try some examples that are a little bit tougher. Okay, I have 2x minus 3y equals 6, and 6x plus 5y equals -10. They are both in the same order. I have x and y on the left, x and y on the left. So I'm good to go after step 1. Step 2, look for a pair of opposites. Okay, I have a 2x here. I'd like that to be a -2x. There's not really an easy way I can do that, but I could do it the other way. That's a positive 6x. I'd like that to be a -6x. Is there something I can multiply this by to make that a -6? Yeah, I can multiply by a -3. Let's check with the y, see if that would be any easier. No, I have a -3 and a positive 5. I'd have to multiply both equations by a number to get those to be the same. Sometimes that's your only choice. Sometimes you have to multiply both equations by something. But if I can get away with just multiplying one side, one equation, by a number, that's going to be a little bit easier. So I want to turn this into a -6 because that's positive 6, so I need to multiply this by a -3. So that is now -6x plus 9y equals -18. So now I have a pair of opposites. I'm going to add the equations together, so I'll write them one on top of another. I don't have anything written under here, so I'll just rewrite this one underneath. And I'm going to add those equations together. 6x minus 6x cancels itself out. 5y plus 9y is 14y. And -10 plus -18 is a -28. So if I divide both sides by 14, it turns out that y is a -2. And if I go back to my original, 2x minus 3y equals 6, I can plug in -2 for y. Minus 3 times -2 equals 6. So now I get 2x, -3 times -2 is a positive 6 equals 6. I'll subtract 6 from both sides. 2x equals 0. Don't freak out. You haven't done anything wrong. Everybody always gets a 0 and they automatically think that it's an error. It's not. 0 is a number like anybody else. I can divide both sides by 2. And 0 divided by 2, that's a number. It's 0. So my answer happens to be at 0, -2. Okay, so don't get nervous because you see a 0. 0 is a number like everybody else. Okay, let's just draw a line here. Let's take a look at these guys. So, are they in the same order? Yep, looks like it. I have x and y on the left, x and y on the left. Great. So, pair of opposites. I have a 4x here and a 9x here. Is there an easy way to get those to be a pair of opposites? Not really. I'd have to multiply both equations by some number. So maybe I don't deal with the x's this time. Let's look at the y's. I have a -y here and a positive 2y here. So if that's a positive 2y, I'd like that to be a -2y. Is there something I can multiply this by to get a -2? Yeah, why not multiply the whole equation just by 2? And that should work. So if I distribute that 2, I get 8x minus 2y equals 10. And now I have that pair of opposites. It doesn't matter if it's with the x's or the y's. You just want one of them to be the same. So I'm going to rewrite this over here and add them together. 8x minus 2y equals 10. I'll add those two equations together. 9x plus 18x is 17x. Positive 2y plus -2y cancels itself out. 7 plus 10 is 17. I can divide both sides by 17. And I get that x is 1. Not so bad. So that's part of my answer. I'll go back to the original. 4x minus y equals 5. I know that x is 1. So I get 4 minus y equals 5. I'll have to subtract 4 from both sides. So I have -y equals 1. So in order to get positive y, I need to divide both sides by a -1. So now I know y is -1. So my solution, 1, -1. Okay? Now, how do you think we go about dealing with something like this where I have a fraction? Well, I'll tell you what, you have a couple options. And I really think that the easiest option is to get rid of the fraction. So, if you remember some from the other videos, we've cleared fractions by multiplying the entire thing by the denominator. And if there's more than one fraction, you multiply by the least common multiple of the denominators. So in this case, if I just multiply the whole thing by 2, the fraction will be cleared. So I have 2y, 2 times 1/2 x is just 1x. So now I have this equation with this one. Is it in the same order? Because I want that. Yes, it is. I have y on the left, x and a number on the right. Y on the left, x and a number on the right. So their step 1 is done. They're in the same order. Great. Pair of opposites. I have a 2y here and just a y here. Could I multiply this by something to get a -2y? Yep. Let's check the x's just for fun. I have an x here and a 3x here. Is there something I can multiply this by to get a -3x? Yeah. So it doesn't matter which one you do. They're both going to be just as easy as each other. So I think I will multiply this guy by a -2. So I'm going to cancel those y's out. So I'll get a -2y equals -6x plus 6. Now that I have the pair of opposites, I'm going to write them on top of each other and add them together. So I'll just rewrite this one over here. 2y equals x plus 4. Now I'm going to add them together. Well, -2y plus 2y is just 0. -6x plus x is -5x. And 6 plus 4 is a positive 10. And I can solve for x. Subtract 10 from both sides. So I have -10 equals -5x. Divide both sides by that -5. And I get a positive 2 for x. I can go back to my original. 1/2 x plus 2. Plug in that x is 2. 1/2 times 2 plus 2. And 1/2 times 2 is 1. 1 plus 2 is 3. So I get my answer of 2, 3. Okay? Let's check out this one down here. Are they in the same order? No. I have y on the left, x and some number on the right. Over here I have x and y on the left and some number on the right. So it doesn't matter which one you make look like the other. That's up to you. I think I will... What will I do? I'll move this x over. So now I have negative x plus 3y equals 18. Okay, great. So now they're in the same order. Perfect. Do I have a pair of opposites? Well, I have a negative x and a negative x. They're not opposites. So I would need to just multiply one of them by a negative 1 so that one would be positive and then I'd have it. So why don't I multiply this guy by a negative 1? So now I have x minus... Oh, I should be doing that in black. Positive x minus 3y equals negative 9. So now now that I have the pair of opposites, I want to write them on top of each other. So I'll just write this one over here. Negative x plus 3y equals 18. And, whoops, when I add them together, x plus negative x is gone. Negative 3y plus 3y is gone, so the only thing left on the left-hand side is 0. And negative 9 plus 18 is 9. Huh. Well, that's weird, but it's not if you watch the last video. What does this mean? If you have 0 equals 9, first of all, 0 is not equal to 9. Not on this planet anyway. 0 is not equal to 9. So I call that a bogus answer, if you recall. And what does that indicate? Do you remember? Remember that a solution to a system, if you were to graph them, for example, it's where the two lines intersect. So if I'm getting this weird bogus answer, that means that the lines never intersect. So what's the solution? There is no solution. Why? How can you have no solution? This is because the lines are parallel. They will never intersect, so you'll never get a solution. Okay, so you might want to verify that either by writing your two original equations in slope-intercept form, and remember that parallel lines, they always have the same slope but different y-intercepts, so you could verify that. Go over your math, make sure that you didn't mess up. But these, we actually did graph these in the graphing video, and they are, in fact, parallel lines. So, if you're going through your math, you're sure you didn't mess anything up, and you get a bogus answer, 0 is not equal to 9. This could be anything. You could have 2 equals 5. No, it doesn't. Anything that doesn't make sense right there, and all your variables are gone, that's what that indicates. So, just verify that they are parallel, and you'll be good to go. Okay, am I going to try and trick you again? I don't know. Yeah, I do. Let's see. Alright, so solving by elimination, I have 2x plus 4y equals 6, and x plus 2y equals 3. So, yep, they're in the same order. That's good. Let's try and get a pair of opposites. Here's a 2x and here's an x. If I just multiply this by a negative 2, I'll get that pair of opposites. Is it any easier with the y's? Nope, it's about the same. I'd have to multiply anyway. So let's just multiply this by a negative 2 and see how that works out for us. So distribute that negative 2. Negative 2x. Negative 2 times a positive 2y is a negative 4y. Negative 2 times 3 is a negative 6. I've got the pair of opposites, so I'm just going to write them on top of each other and add them. So I'll rewrite this one down here. 2x plus 4y equals 6. Add them together. Negative 2x plus 2x is gone. Negative 4y plus 4y is gone. So the only thing left on the left is 0. Negative 6 plus 6 is 0. Nowhere for me to go. Well, is this the same as the problem we just did? No, it's totally different because 0 really does equal 0. That's not a false statement. That's true. I just have nowhere to go from here. So if you remember, this means, so this is a true statement. It's true. 0 is equal to 0. This means, do you remember? There are infinite solutions. Why? Because the lines are, do you remember the fancy word? Coinciding. And remember, coinciding means that they are literally the exact same line. Same slope, same y-intercept. So you could rewrite these in slope-intercept form and realize that, yep, they are in fact the exact same. Actually, just look at the two originals. If I just took this one and multiplied it by a positive 2, don't I get exactly that? So they are certainly the exact same. So whenever we have that, there's infinite solutions. The lines are coinciding. Okay? And I just wanted to take a look at this last one here. So this was the same one from the graphing video, if you had watched that one, and the one from substitution. Not all of your answers always come out as nice numbers. So when we had graphed this one, we had an approximation. So I just want to show you that solving by elimination, you can also get an exact answer. Unlike graphing, if your solution doesn't happen to be at a lattice point, with graphing, you're going to have to be estimating. But with elimination or with substitution, you can get an exact answer. So let's just follow our steps. I want both equations in the same order. They are, but I have a fraction here, so I don't really want to deal with it. So I'll multiply this whole thing by 2 just to clear the fraction. Make my life a little bit easier. 2 times negative 1/2 x is a negative x, and then plus 6. Okay, and that equal sign looks a little funky. Okay, so they're in the same order. Check for a pair of opposites. 2y and y. This would be really easy to make into a negative 2y. I just have to multiply by negative 2. But hold on, look. You have a negative x and a positive x. You already have a pair of opposites. You don't have to do extra work. So I have the pair of opposites. Let's rewrite this one right underneath. Y equals x plus 1. And I'm going to add them together. 2y plus y is 3y. Negative x plus x, they cancel each other out. And 6 plus 1 is 7. So I can solve for y, divide both sides by 3. And 7/3, I can rewrite that as 2 1/3 if I like. Okay? So I can take 2 1/3 and plug it in over here. I know that y is 2 1/3. X plus 1. So I just want to solve for x. I can subtract 1 from both sides. And luckily that's pretty easy to do. I just end up with 1 1/3. Okay, so my solution, just like when we solved it by graphing and by substitution, 1 1/3, comma, 2 1/3. Nice. Okay, I hope this helps you solve by elimination. Good luck.